What is going on, guys? Welcome to this Python course for network programming. In today's video, you're going to learn network programming principles in Python taught on 4 different projects. So we're going to do a mailing client. We're going to learn how to automate mails. We're going to learn how to do a DDoS script. So a little bit of penetration testing there. We're also going to build a threaded port scanner, which is essentially just a port scanner on steroids. So it's going to scan multiple ports at the same second. And we're also going to build a TCP chat that allows you to chat with the server and multiple clients connected to the server at once. So I hope you enjoy this video, and let's get right into it. Now let's get started with the code. The first thing we need to do is we need to import the SMTP library of Python. SMTP is the protocol that we're going to use to send mails, because what we need to do here is we need to take our script and log into an existing mailing account. So make sure you have one. You log into an existing mailing account, and then you use the SMTP protocol with your Python script in order to send mails from that account to other accounts. So you cannot just send mails directly from the Python script. You use the Python script to log into your existing mail account and then use the SMTP protocol to send mails from there. So this is what we're going to do, and for this we need to define a server. The server is defined by smtplib.smtp, and here you have to specify the SMTP server and a port. And the port we're going to use is 25 for SMTP. And the SMTP server address is usually something that you can find out by Googling. So you just type in SMTP server Gmail, SMTP server Yahoo, whatever provider you're using. So smtp.gmail.com, for example, is the one for Google. It's a very basic format. Actually, you always write SMTP dot. Most of the time, it's just going to be dot whatever your provider's domain is. In my case, I'm using an Austrian provider here where I'm hosting my website, which is worldforyou.com. So smtp.worldforyou.com is the address of my SMTP server here, or of the SMTP server of my provider. And once we have that, we're just going to start it, to start the whole service here by calling the ehlo command. So this is the function you need to call to start the whole process. And now the next thing that we need to do is we need to log into the account. So you have your SMTP server at Gmail or whatever it is, and then you just log into your account. And to do that, of course, you need the information first. You need the email and the password. And I would never recommend saving the password clear text in your script, because what you essentially need to do is you need to say server.login, and then you have your mail here, mail@mail.com, whatever, and then your password here, password123, whatever it is. You can do it like that if you want. If you're just using the script with a crappy mail account that you don't need, just for experimentation, you can do it like that. But I would not recommend it. What you should usually do is you should save your password, encrypt it in a text file, then load that text file, decrypt it, and then use that password. For this tutorial, I'm just going to save the clear text password, or actually save the clear text password already in a text file, and I'm going to read it here so that you, as a viewer, are not able to see it. So what I'm going to do is I'm going to say with open, I'm going to open a text file stream with open password.txt in reading mode as f, and we're going to say password equals f.read. So now I have the password that I saved in this password.txt file. I now have it in the script, and I'm going to say server.login, and now you have to specify your mail. So whatever, maybe yours is alex@gmail.com, whatever it is. In my case, I created a separate email for this tutorial. So mailtesting@neural9.com. And the password is the one we just loaded. So this is how you log into your server, into the SMTP server, into your mail account, and now we can start creating the message. Now, before we can start creating the mail message, what we need to do is we need to import some additional libraries, because what we're going to do is we're going to create a message, a mail, consisting of multiple parts, of attachments, of messages, of headers. And for this, we need to import some additional libraries. So let's start with from email import encoders, which is something that we're going to need later on in this video, not yet. And also let's say import, not frozen set, from email import mime text, which is the ordinary text that we're going to use. Actually from email.mime.text import mime text. Then from email.mime.base, we're going to import mime base, which is what we're going to use for the attachment. And then for the whole thing, we're going to use mime.multipart import mime multipart. That's it, and now we can start creating the message using these libraries here. So the first thing that we're going to do is we're going to define the message as a mime multipart, and we're going to define the header. And the header is essentially consisting of a from, to, and a subject. So we're going to say message equals, or actually message from equals, because message can be treated like a dictionary. We can just say, okay, message from equals, and here we're going to say neural9 or your name, whatever you want. You can put here all kind of creative stuff. And then we can say to, and here you usually just specify the target email. In my case, I'm going to use a 10-minute mail, but I'm not going to use the 10-minute mail domain, because the 10-minute mail domain for some reason is not able to receive attachments. I tried it, at least when I was experimenting with my script. I couldn't receive attachments there. So I'm going to use a German spam mail provider, which is providing 10-minute mails. And the domain is called spammel.de. So I'm going to just say mail testing at spammel, or actually this is probably not that intelligent, because my mail is already mail testing. Let's say test mails at spammel.de. You can use a different one. You can also use your existing email, a real email. I'm just going to use a spam mail for this video. Then we're also going to say subject equals whatever you want it to be, just a test. This is essentially what you're going to see once you receive the mail in the subject. And that's essentially it. Now you can specify a text for your message. And I usually do this in a file. So we're going to create a new text file here. We're going to say message.txt. And here we're going to just write our mail message, hello world. This is a mail sent with Python. Subscribe to neural9. Always got to do this, as we're used to it already from the other videos. Kind regards, neural9. There you go. Then you have the message here. And what you do then is you just load the message the same way you loaded the password if you loaded it. So with open message.txt in reading mode SF, we're going to say message equals f.read. That's essentially it. And this is something that you just need to attach to the message object here. So message.attach, which is not the attachment. We're going to add the attachment later on. So we are not adding, oh, sorry, not .text.txt. You're not adding the txt file to the mail. You're adding it as a text. And we're later on also going to add an image as an attachment. So what you need to do now is you need to attach mime text. And you're just going to pass the message here. And you're going to attach it as plain text. So this is how you add a header and a text to your message object. Now, one more thing that we want to do before we send the actual message is you want to attach an image to it. So in this case, I downloaded a royalty-free image from Pixabay. You can also use Google Images if you're just using it for your personal experimentation. You're not going to get sued for that. So I just picked this coding.jpg file from Pixabay because I'm doing a video and I shouldn't be using copyrighted images here. However, you get this image, put it into the same directory, and then you specify the file name. File name in this case coding.jpg, or essentially the file path. If it's somewhere else, you can also specify the whole path. And then we're going to open up attachment equals open. We're just going to open a file stream of this file name. And now we're going to open it in reading binary. So we're not going, or reading bytes. We're not going to open it up in reading text mode, but in reading byte mode, because we're using, we're working with image data here, not with text data anymore. So the next thing is we're going to create a payload object. So we're going to say p equals, and now we're going to use this mime base object. So we're going to say mime base, and here we're just going to start a so-called, don't ask me what it stands for, it's a application, and then it's called an OCTET stream, which is essentially the stream that we're going to use to process this image data here. And then we're going to set the payload of this payload to attachment to the file stream dot read, or actually like that, attachment dot read. I'm not sure if we even need those parentheses here. I don't think so. So attachment dot read, and this is what you set as the payload. You just read the content of this attachment with reading byte modes, and you set the payload. Now the next thing you want to do is you're now going to use the encoders. So we're going to say encoders, encode base 64. So we're going to encode the image data that we just read and that we set as a payload. We're going to encode P, and then we're going to add a header to P. So we're going to say p.addHeader content disposition, and we're going to use an F string here to say application or attachment, attachment semicolon, and then file name. And now of course we add the file name here, which is just file name. And this is how you add the attachment. Of course, now the payload, the attachment itself has to be attached to the message. So we're going to say message.attach, message.attach P, and that's how you add the actual payload to the message. Now the last thing we need to do is we need to say text equals message dot as string. So we finally get the whole thing as a string, and this string can then be sent by the server. So we're going to say server.send mail, and we're going to send it from mail testing at neural9.com to our target. What was it? Testmails @spaml.de, and we're going to send the message, which is the text. Now this is the whole script, and we're now going to test it. So now what I did is I created a spam mail on spaml.de. It's German, don't get confused by that, but you can also use any other spam mail provider, or you can just use a real mail as a target. In this case, I just didn't want to use or show any of my personal emails, so I used this test mails at spaml.de. And now what we're going to do is we're going to run our script. So we're going to say run. And if we didn't make any mistakes, this should now send the email without any errors. Wow, we didn't get an exception. I'm surprised, to be honest. And now let's wait for it and see if we get something here. And you get it here, just a test. Hello world, this is a mail sent with Python. Subscribe to Neural 9. Kind regards to Neural 9. You can also see that Avast was checking this mail. So if you don't want this message to appear, just if you're using the same antivirus software, just turn it off. And you can also see that there's an attachment in here, coding.jpg. And if I download it, you can see that it's the exact image that we wanted to send. So it worked. The script worked. You have Neural 9 at unknown. I don't know if we have the mail header here somewhere as well. But if you're using a normal mail account, this should appear as Neural 9 as, or your mail, not Neural 9, as in this case, mail testing at neural9.com. In this case, it says Neural 9 at unknown. I don't know why it does that. But essentially it works. The subject is here, the text is here as a normal text, and then we also have the attachment. So it worked perfectly fine. And that's basically it. We're going to code a distributed denial of service script, which is basically a script that overloads a website with requests so that this website is not able to offer its service anymore because you're overloading its capacities basically. So before we get into the code, let's talk a little bit about how DDoS basically works. You have one attacker, and this attacker chooses a target, for example, the server of a shop or of a newspaper or something, and says, okay, I want to take this site down. So what do? I send 5,000 or 10,000 or 50,000 requests per second so that the server will be overloaded. The capacities are not enough to handle all these requests. And as an effect of that, if a normal user wants to connect to that website, it's also not possible because you're getting 50,000 requests per second. So if I, as a normal user, as a customer, want to visit that website, I'm not going to be able to do that because the hacker is already, or actually DDoS is not hacking, but the attacker is actually flooding the server with requests, so I cannot visit the site as well. Now, of course, you can counteract this by blocking the IP address of the one who's sending all these requests, or actually blocking all the IP addresses except for your own, and then do some stuff in the backend or something. But usually that is how it works. You have an attacker, and this attacker chooses to take down a website by flooding it with requests. Now, first of all, before we get further into this video, I want to mention that DDoS is highly illegal. So if you do it on your own server, do it off the server, onto the server of someone you know that gives you permission to do it. Don't just go ahead and DDoS Amazon or any other web page, because you can get sued and you can get imprisoned for that. So I am not responsible for what you do with this knowledge here. It's purely educational. I'm not encouraging you to attack certain websites or something. So this is just so that you understand how it works, how to implement it with Python, and then you can penetration test your own systems with it. But don't go ahead and attack some strangers or some websites of other people. Having said that, let's talk about how this is done when you're attacking bigger targets. Because in the year 2010, I think, Anonymous took down PayPal because of the whole Julian Assange affair. But of course, the problem is that PayPal is quite a big service. And if you want to take down PayPal, and of course you shouldn't do it, but I'm just saying, if you want to take down a big target like PayPal, you cannot just go ahead on your own and run a script. What you do is you use a so-called botnet. So you infect other computers. These people don't know anything about it, but you just go ahead and you infect your computer, for example, my computer, just people that don't know what's happening, and you're basically having them as your zombie army. It's not about harming these people, so you're not infecting their computers with a virus, deleting their file, encrypting their files, or getting information from them like passwords or something. You're just using them as your army, so you're using them as your soldiers. So they will probably not recognize that you're even taking control of them, because you're not doing anything with them unless you want to attack a target. So if you have, let's say, 50,000 computers in your botnet, you have 50,000 people, for example, grandmas or people that don't know anything about coding, anything about networking, about hacking. They're just using their computers, but when you say start, they start executing the same script as you are. So you're basically saying, okay, I want to hack PayPal. I use my botnet. All these 50,000 computers are going to run this script right now, and everyone is flooding PayPal with 50,000 requests per second. And 50,000 times 50,000 is a pretty big number. And of course, what happens in addition to that is this is just one attacker with one botnet. And in the attack on PayPal, you had multiple attackers with their own botnets DDoSing PayPal. So this is how they took down PayPal. And again, I'm not recommending you to do that. I just want you to know how this happens. And I want you to understand how this works so that you can maybe penetration test your own systems with it, or even take some counteractions, security measures based on that knowledge. But that is basically how DDoSing works. So now let us get started with the coding. And the first thing that we're going to do is we're going to import threading, and we're going to import socket. Socket because we're going to use it to connect, and threading because we're going to run multiple threads. Now, one more thing that I need to mention here is Python is maybe not the best language to do this, because Python doesn't support real multi-threading. So if you're doing multi-threading in Python, it's not actual multi-threading, it's simulated multi-threading. So you're basically switching between the tasks as fast as possible, but it's not actual multi-threading. So you might want to use a different language for that, but it still works since it's sending a lot of requests at the same time, just so that you know what's happening in the behind the scenes, basically. So what we need here first is we need a target, and this target is usually an IP address, but it can also be a domain name, because the domain name can be resolved into an IP address. But what I'm going to do here, I'm going to just DDoS my own router, and I recommend you to do the same unless you have a website on your own. So if you have, I don't know, if your name is John Stevenson or something, and you have johnstevenson.com, please don't DDoS johnstevenson.com if it exists. But if this is your webpage, go ahead and DDoS that webpage. But other than that, just keep it in your own network. So DDoS your router, DDoS your own laptop, run an Apache server onto your own system, and then DDoS that if you want. But don't go ahead and DDoS some other websites. It's highly illegal, again. So the IP of my router, my inside IP, is 10.0.0.138. And if you want to know what your IP is, you can just go ahead and say cmd, okay, and then you say ipconfig, and you're going to see wireless LAN adapter, since I'm using wireless LAN here. You can see your own IP. This is the IPv4 address, which is the one that you're using in your own network. So this is not a public IP address, otherwise I wouldn't be showing you that. This is just in my network at home. This is my IP address. And the default gateway is my router, so this is the IP of it. So if you want to DDoS your own router, you can just go ahead and say DDoS this IP address here. It will be probably different in your system or in your network. However, depending on the port that we're DDoSing, different things can happen. So if I DDoS on port 22, I'm DDoSing the SSH service, so the command line service, the secure shell service, and the website will still work. If I DDoS port 80, I will DDoS the HTTP port, so the web interface might be down. So depending on which service I'm going to take down, or I want to take down, I'm going to attack a different port. In this video, we're going to attack HTTP, so I'm going to say port equals 80. And what we can also do here is we can specify a fake IP for the header. However, please don't think that you're anonymous just because you specify a fake IP in the header. You, of course, need to use anonymization tools, so you cannot just go ahead and change the HTTP header and then think that you cannot be recognized as a hacker. But still, it's a nice extra that you can add to your script. So you can say fake IP equals, and then you just choose an IP, whatever it is. Let's just choose 182.21.20.32. And that's just one sample IP that you can have. And these are the things that you need in order to specify the target and also add your own fake information into the header. So now we're going to define the actual attack method, and this method doesn't look like an attack method because it's basically just an endless loop running a socket connection. So what we do is we say def attack. We need to define a method here so that we can later on refer to that method in the threads. And what we do is we say while true, basically an endless loop, and then we say as equals socket.socket socket.af inet, which is basically just creating a new socket, an internet socket, and then specifying the protocol, which is TCP, so sock stream. And when we've done that, we just say s.connect to the target on the port. We need to pass a tuple here. And that's basically it. Now we have to send the header. And for this, I'm going to copy the 2 lines from the website just because I don't want to remember the whole format here. As I said, you can find the text-based version on neural9.com. So if you want, you can just, copy it from the website or type it in manually. We just say get / then we enter the target. Then we say specify the HTTP version, encode the whole thing, and send it to the target on the specific port. Then we also say host, enter the fake IP address, encode it, and send it to target and port. And after that, we just close the connection. That's basically the whole attack method. It's just constantly connecting, sending, closing, connecting, sending, closing over and over again. But of course, this would not be enough. We need to run this in multiple threads. So what we do is we basically say for I in range, how many threads do you want to run? You can say 500, for example, or 50 or 5,000. What we do is we say thread equals threading.thread, and we basically specify target, but this time this is not the IP target, but the target function, and this is attack, and then we say thread.start. And that's actually it. That's actually the whole script. We just have an attack method. We have the 500 threads that run this attack method. When we run this, the connections will be made, but of course we won't see anything. If you want to see how many connections have been made all the time, of course this will slow down the script. So printing the connections, printing the amount of connections already done will slow down the script. So what we can do is we could say already, I don't know, attacked, or okay, not attacked, already connected. It's a stupid name, I know, but let's say 0. What we do then is when we close the connection, we just say, okay, global, so that we can access this already connected variable. global already connected, and then we say already connected plus equals 1. And I think that's actually it. Let me take a look. Oh, of course we need to print it, sorry. And then we can just print already connected. Yeah, and then we can run it and see what happens. You can see immediately we have around 500. Of course, it's way faster if we don't print all the numbers. So what we can do is we can say if already connected modulus 500 equals 0, which basically means every 500 connections you can print it. What we do is we just say print already connected. So it will only print every 500 connections. Still, or did I make a mistake here? Oh no, actually it's that slow. So it's probably not a good script at all, but still, it works. Or maybe it's that slow because I'm asking all the time. I don't know. However, basically this is how you do it. You define a method that sends a connection in an endless loop, and then what you do is you basically run multiple threads at the same time attacking. Then you have bots or a botnet with computers that all run the script at the same time. And then maybe you also have multiple attackers, and in the end you take down a service like that. Of course, you can, again, specify different ports. Then this part here doesn't make a lot of sense, but you can also try to take down the SSH server or other services, whatever. But this is how you basically do it. You define a method, run multiple threads, and then you take down a system. So that's it for today's video. Again, this episode was purely educational. So first of all, the script is not optimal. You would not use it for an actual DDoS attack. It's not a good script. You wouldn't use it. It's just so that you can get an understanding of how something like this could be done. But no one would ever use this Python script for a DDoS attack. First of all, because it's slow. Second of all, because it's not really heavy. You're not sending a lot of data. But it's just to see how you could do this in Python. Second of all, if you're using DDoS, this script or any other script, keep in mind it's illegal. Use it on your own systems. I mentioned it 2 times before, but it's very important, and you shouldn't, do any harm with these scripts. We're going to create a port scanner in Python, which is going to allow us to find open ports in servers, computers, printers, basically any kind of host. And we're going to use multi-threading to make this port scanner as fast as possible. So we're going to run multiple threads so that we can scan hundreds of ports per second. Now, before we start with the video, let me tell you that you can find a text-based version of this tutorial at neural9.com, which is a blog post. And there you'll also be able to copy the code if you want. So if you're interested in that, check that out. You'll find a link in the description, and you can also check out the other blog posts about machine learning, programming, and so on this page if you're interested in them. So let's get to port scanning. Now, first of all, why scan ports? Why are we interested in open ports? We're interested in open ports because an open port, especially an unnecessarily open port, might be a security gap. And we always want to find security gaps either in our own networks to make sure that our network is secure enough, or if we have bad intentions and we are hacking, we want to find open ports in networks of other people. Now, notice that port scanning is illegal. Even though it's not a hacking attack in and of itself, it's an illegal act. So don't scan networks that you don't have any permission for. Only scan your own network, your own computers, your own servers. Don't do this for exploitation purposes. So I've warned you, I don't take any responsibility for what you're doing. This content here is purely educational, so if you use it for something bad, it's your fault and I do not advise it. Now, let's get into port scanning itself. How does port scanning work, or how are we going to scan ports? Now, what we're going to do is we're going to use sockets to connect to a certain target, to connect to a certain server or IP address at a specific port. If the connection succeeds, we're going to say this port is open. If it does not succeed, we're going to say this port is closed. And to do that, we're going to implement a port scan method. So let's start with that. We're going to import the socket module, and we're going to say def port scan. and we're going to pass a port here. Now, to scan a port, as we said, we have to try to connect. So what we're going to do is we're going to create a socket first. Socket.socket, socket again, .af enet or inet, which stands for internet. Basically, we're just saying, okay, this socket is an internet socket and not a Unix socket. And the second parameter is socket.sockstream, sockstream, which basically just says that we are using TCP instead of UDP. Now that we have created a socket, what we're going to do is we're going to connect. And before we can connect, we have to define where we're going to connect to, because when we use the connect method, we have to pass a tuple. And the first part of the tuple is the IP address, which would be our target. And the second one, the second parameter here is the port. So the port is actually the parameter of this function, so we can just pass it. But the target, we have to define a target. And as I said, use your own computers, use your own servers, or servers that you are permitted to use. So do whatever you want, but don't scan the network or someone else that you don't have permission to. So basically just pick a device from your home. Now, in my case, I'm going to pick my router, which has the IP address 10.0.0.138, and it's my default gateway. If you don't know what IP address to choose, you can always pick localhost. Localhost would be 127.0.0.1. This would be your own machine that you're operating on right now. So if you don't know what to scan, just scan your own computer that you're working on right now. Now, what we're doing here is we're saying connect to the target, which is our IP address here, and we're saying connect on this particular port. Now, if we don't get any errors or any exceptions up until now, the connection succeeded and we can return true. This means our port scan was successful, or basically the port scan was always successful, but our port is open. So we found an open port. The connection was successful. If this is not the case, so if we get some exception, some error, we're going to just return false. Now, with this method here already, we can scan ports. So I can just say print port scan 80 should be open because it's HTTP. And as you can see, I get true. Now, if I check for another port, maybe 98, hopefully it's closed. Yeah, it's closed, so I get false. So whenever I cannot connect to a port, I return false, and every time I can connect to a port, I return true. So this is how this method works. And we could go ahead now and just write a for loop for port in range, and then just define a range of ports, for example, from 1 to 124, which would actually just scan up until 123. These are the so-called standardized ports that are reserved for HTTP, FTP, and SSH, Telnet, and so on. So we're going to say scan all of these ports, and every time I get a result, which is either true and false, so port scan port. So we're scanning the port that we have right now in the loop. And then we say if the result, we can just say if result since it's a Boolean. So if true, if false, you know, if the result is true, we say print port whatever is open. And we can format in the port number. And otherwise, we just print port whatever is closed. Format port. So when we run this, you'll see that it starts checking for all the ports, like port 1 is closed, port 2 is closed, and so on. And it continues to do that in a very, very slow pace. As you can see, we barely make any progress. It's very, very slow. Now to change that, what we can do is we can introduce multi-threading, as I said. And to do this, we cannot just start 30 threads because it would be very inefficient to just run multiple threads. Because if we just run multiple threads, what happens is we can, or the possibility is there that we check the same port number twice. So to make this as efficient as possible, we're going to use so-called queues. So we're going to import two more libraries here. First of all, import threading because we need the threads, and also from queue import queue with a capital Q. So a queue basically is like a collection or like a sequence, like a list maybe, where we have all kinds of elements. And every time that we get an element from this list, it's no longer in the list. So we are basically queuing the elements. In this case, we're queuing the port numbers. And I can say I have all the port numbers from 1 to 1000. And every time I get one, the whole list, the whole sequence shifts and I can get a new one. We'll see how this works in a second. But first of all, let's remove this loop and start by defining an empty queue here that we're going to fill up later on. So queue equals queue. And I'm also going to create an empty list with for the open ports actually. This is the list where at the end we'll add all the open ports so that we can see which ports are open in a final report. Now what we're going to do now is we're going to fill up this queue. And to do this, you can choose whatever method you want. You can just fill, I don't know, 10,000 ports numbers into it. You can fill just a list of numbers into it. You can write your own method if you want. What we're going to do right now is we're going to define a method fill queue, and we're going to say from port and to port. So we're going to define a range. You can also pass a list, it doesn't matter. Basically, you're just saying, or let's do a list actually. I think it's more, it's better. Let's say port list. We're going to pass a port list. And what we're going to do is very simple. We're just saying for port in port list, we are going to put in every port into the queue. Now the queue operates by the first in, first out system. So the port that enters the list first is the first to get scanned. So I'll start putting in 1, 2, 3, and these are the ports that will be scanned first. So I'm basically just taking the list that we can pass later on, and I'm filling this list into the queue. Now the next step is to define a so-called worker method, because the worker method is the actual function or method which our threads are going to be using. So when we run a thread, we want it to execute this function, and this will be the port scan actually. So we're going to say for every thread is going to execute this, while not queue.empty. So basically, as long as there are elements that are not scanned in the queue, as long as the queue is not empty, what I'm going to do is I'm going to say port equals queue.get. So I'm going to get the next port in the list. Since it's not empty, I'm going to get one. And then I'm going to say if port scan of this port returns true, I'm going to print port whatever is open. And we're going to say format port. And additionally, we're going to add the port to the open ports list. So we're going to say open ports.append port. So we're adding our port to the open ports list so that we can have a good final report in the end. Now, otherwise, if you want, you can also print port whatever is closed. But when we run that many threads, it will be very, very hard to find the open ports because we'll have a lot of statements at the same time. So I think it's more beneficial to just print the open ports, just so we get a better overview of this. So we're going to delete this, and we're only going to print something if the port scan returns true. Otherwise, we're not going to do anything. So these are the functions that we're going to use. Now what we need to do is, first of all, we need to fill our queue. And we can do whatever we want. You can say, I want all the ports from 0 to 5000, or I want only 22, 80, 443, and so on. Only the important ports that I'm interested in. Just define your own list if you want. I'm going to say port list equals range 1 up until 124. And now I'm going to say fill queue port list. So the next step is to define an empty thread list. And I'm going to explain in a second why we need a list for our threads, because actually to run the threads, we don't need this list, but we're going to need this list later on, because otherwise the last part of this script is not going to work. So first of all, we're going to say for t in range. And now we're going to specify the number of threads that we want to run. So do you want to run 10 threads? Do you want to run 20 threads, 100 threads, whatever? So let's start with 10 threads, so range 10. And now we're going to say thread equals threading dot thread with a capital T. And we're going to say target equals worker. Notice that we're not calling the worker function here, so we're not saying worker in parentheses, we're just saying worker. So we're referring to the worker function without actually calling it. Now what we're doing here is we're creating 10, so range 10, so 10 times we're creating a new thread with the worker as the target function. And then what I'm going to do is I'm going to say thread list dot append thread, and then we have all these threads that we created right now in our list. Now the next step is to run all of these. So we can say for thread in thread list thread dot start. And last but not least, this is the important part why we need the list. We're going to wait for all threads to finish. So we're going to say for thread in thread list thread dot join. The join method waits until the thread is done, until it continues with the code. So after this statement here, we're going to print the open ports are and open ports. And the reason we have to join here is because we don't want this to get printed until all the threads are done. So we only want to print all the ports that are open in the end when every thread is finished. So basically that's it. Now let's run this. When we run this, you will see that we're going to make progress quite fast. So we already reached 22, 25. And it scans 10 ports per second, more or less. We have 10 times the speed that we had in the beginning. So as you can see, we already reached port 80, but it's still not the fastest. So if we want to have this even faster, we just don't say 10, but we can say 100. And then it will already scan 100 ports. So we already scanned port 80, 143, and so on. And it's way faster. And we can keep increasing the number as long as it seems to be faster, because, you know, sometimes or at some point you will reach a limit and your computer is not going to execute faster. But you can try with 500, for example, and you will immediately reach 500, as you can see. So it's quite fast. I think when you say 1,000,000, it's not, it will not be faster, but as you can see with 500, it works quite well. These are the open ports, actually quite a few, and I'm going to have to take care of that because obviously a lot of ports are open in my router. We're going to develop a TCP chat in Python. So we're going to set up a server, and we're going to set up multiple clients, and these clients can then connect to the server, which works as a chat room, you could say. And each client can then send messages to the server with his or her nickname, and all the other clients can see these messages and respond. So let us get into the code. Now, the first thing that we're going to do is we're going to create a server file. So we're going to right click onto the directory and create a server.py file. And in here, we're going to import threading, import threading and import sockets. These are the two modules that we're going to need in this video. And if you don't know how to work with sockets, or you don't know what sockets are, you don't know what multi-threading is, I highly recommend that you check out the Python intermediate tutorial series on this channel, because there I talk about network programming, about multi-threading, what these things are. I also have a tutorial on how to make a port scanner, a multi-threaded port scanner, where I use both concepts. So check out these videos, because I'm not going to go too much into the details of threading or sockets in this video. Now, the first thing that we need to do here is we need to define a host address and a port for our server. So the host in this case will be just 127.0.0.1 because we're using localhost. So let's add a comment here, localhost. This is just because we're running this on our machine. If you run this server on a web server, you should always pick the host address of the server. So always the IP address of the server. This is just the basic localhost. Since we're running it on this computer, it will be localhost. Then we need a port, and as a port, you can choose whatever you want. You could just go with 99872 or something like that. What you shouldn't do is you shouldn't take ports like 80, because this is HTTP, and you should just not pick any reserved ports or well-known ports at all. So just don't choose any ports from 1 to, I don't know, I think 10,000 or something. But we're just going to go with 55,555. This is a solid port. And then what we need to do is we need to start the server. So we're going to say server equals socket.socket, and in here we're going to say it's an internet socket, so socket.af inet, and then we're going to say it's socket.sockstream. So again, if you don't know what that means, socket.sockstream. If you don't know what that is, and if you don't know why we're creating a socket in that way, check out the intermediate tutorial series. There we talk about these concepts. So next thing is we need to bind the server to the host and the IP address. So we say server.bind, and we pass a tuple of host and port. So we're saying, okay, the server is bound to the local host on port 55555. I think this was 5 times 5, hopefully. Then we say server.listen, which basically puts our server into listening mode for new connections. So as soon as we say server.listen, the server starts listening for incoming connections. Now, what we're going to do next is we're going to define a couple of methods. We're going to define 3 methods. The first one being a broadcast method, the second one being a handle method for client connections, and the last one being a receive method, which basically combines all the methods into a main method, you could say. But before we do that, we're going to define 2 empty lists here, and these 2 empty lists are the clients list and the nicknames list. So these 2 lists will be the lists where we put all of our clients in. So if we have a new client connecting to the server, we're going to put it into the clients list. And also we're going to get the nickname of this client, which the client can then later on choose. And we're going to say, okay, the client X has the nickname, I don't know, Bob or something like that. And then we can just use clients and nicknames to do certain things later on. Now, the first function that we're going to define here is the broadcast function. It's a very simple function. It's just a function that sends a message to all the clients that are currently connected to this server. So we're going to say def broadcast, and we're going to pass a message here. So we're going to say broadcast message, and then we're just going to say for every client in the clients list, which now is empty, but later on we're going to fill it up. For every client that is now connected to the server, we're just going to say client.send this message. Very simple. We're just getting all the clients and sending a particular message, and this is how you broadcast messages from a server to all the clients. So the next thing that we want to do is we want to handle the client connection. So when a client connects to the server, we want to receive messages from the client if the client is sending any. And then we also want to send back messages to all the other clients depending on what the client sends. So if client A says hi, we want to get this message, process it, and then broadcast it to all the other clients, including also client A itself, because every client needs to see what's happening in the server. So what we want to do is we want to define a handle function, and we want to handle one particular client. So we're going to later on run this function on all of the individual clients, but for now we're just handling one single client. So we're getting the client, and what we do is we say while true, basically we're starting an endless loop here. We're saying try a certain thing. So as long as it works without giving you an exception or an error, we're going to just say message equals client.receive, I think it's like that, RECV, 1024 bytes, just the basic message. So what we do here is we say, okay, as long as it works that we receive a message from the client, we're just going to broadcast it to all the other clients. Or, oh, sorry, no, broadcast a message to all the other clients. So what we're doing here is we say try to receive a message from the client, and if that succeeds, broadcast this message to all the other clients, including this client as well. If that doesn't work, so if we get some exception, some error while receiving the message or while broadcasting, what we're going to do is we're going to just cut the connection to this particular client, remove it from the list, and then basically terminate this function. So we're going to say, or terminate this loop. So we're going to say the index of this particular client is the clients.index of this client, and we need this index in order to remove the nickname and the client from the list. So we're just getting the index, okay, where is this particular client that failed right now in the list? Which index does it have? And then we're going to say clients.remove client. So we're going to just remove the client. We're going to close the connection to the client. And then we're also going to say, okay, the nickname of this client is the nicknames index of the client. So basically, whenever we're adding a client, we're also adding the nickname, so they will always have the same index. And when we remove a client, we also remove the nickname on this particular index so that we don't get any inconsistencies here. So what we do then is we say nicknames dot remove nickname. And you could either print it before that, I'm going to print it before that, or you can print it afterward. We're just going to broadcast to all the clients that this client has now left. So we're going to say broadcast, and we're going to use an F string here, and we're going to say nickname left the chat, for example. And then we're going to encode this message in ASCII code so that we get the right message. So after that, of course, we're breaking out of the loop, and that's it. So we're handling a client, one client connects, and what we're doing is we're constantly trying to get messages from this client. This will not give you an error if the client is not sending anything, but it will give you an error if this client is not there anymore. So as soon as a client produces some kind of error, what we do is we just remove it from the list, remove the nickname, and broadcast to all the different clients connected to the server that this client has now left, and then we just terminate this function. So this function will later on run in a thread. For each client, we'll have a single thread running and processing this particular function, or actually executing the handle function. And as soon as a client disconnects, what we do is we just break this loop and therefore terminate the function, therefore terminate or end the thread. So this is how we're going to handle the client connection. So now, last but not least in the server, what we're going to do is we're going to define the main method, the receive method, which combines all these things that we've written up until now into one function. So we're going to say def receive, and we're going to just receive client connection. So we're saying while true, what the server is doing, it is basically accepting all the connections. So we're going to say client and address equals server.accept. So what's happening is we're running the accept method all the time. And if this method gets a connection, what we get, what it returns is a client and the address of the client. So in this case, we're always going to have the same address since we're on one computer. But if you have this running on a server, you'll see the address, the IP address of this client connecting to your server. So basically, we're connecting to clients, or we're allowing the clients to connect. And if this is done, if this happens, if a client connects, we're just going to say print on the server itself. This is not a broadcast. This is just on the server console so that we see what's happening. Connected with, and let's make an F string out of this, connected with address. So that we know, actually we should say str address double D. There you go. So we're waiting for a connection. We're accepting all the connections coming. And if a connection happens to come, in fact, come in this moment, what we do is we just print that we now connected to this client on this particular address. And then, of course, what we want to do is we want to get the nickname of the client. So the client will be able, before it connects to our server, to choose a nickname, and it will then be the nickname that is displayed on the server. So what we need to do first is we need to ask the client for the nickname, because of course, if it just sends us a message, we're going to process it. But the first message that the client sends to us should be the nickname. So what we're going to say is we're going to send a message to this client, and this message will be a code word which is not visible to the user of the client. It's just visible to the client itself later on in the code. We're going to send the keyword nick, and if the client receives this keyword nick, it should be informed that it should send the nickname to the server so that the server knows who are you. So we're going to say encode ASCII again, and we're basically just sending this keyword. And in the next step, what we hope to receive from the client is the nickname itself. So we're going to say client.receive, and we're going to receive 1024 bytes and decode them from ASCII. So then, of course, what we're going to do is we're going to say nicknames.append nickname and clients.append client. And then what we need to do is we just need to send a couple of messages here. So we're going to say, okay, print nickname of the client is, okay, so there you go, nickname of the client is, and then nickname of the client just connected is whatever. And then we're just going to broadcast that so that every client that is currently connected to the server knows that this client is now connected, and that's the nickname of this client. So we're just going to say fstring nickname joined the chat. And we're going to encode this message again. And then every client knows that there is a new client in this chat, and they get a message that this client just joined the chat with the respective nickname. And then we're going to send the particular client that just connected. We're going to send to the one client that this client connected to the server. So we're going to say send connected to the server, so that the client knows that it's now connected and it can start chatting. And of course, we're going to encode this message as well. Now we're almost done. The last two things that we're going to do is we're going to define a thread and run a thread. So we're going to say thread. As we said, we're going to run one thread for each client connected, because we need to handle them at the same time. We cannot just handle them serially, because one client might send something and another client might send something, and we need to process it at the same time, or at least roughly at the same time, and not just, process one client interaction, then start with the next one. So what we're going to do is we're going to say threading.thread, capital T, and the target of this thread will be the handle function, and the arguments will be just client. And then we're going to say thread.start. And if you know how to deal with Python threads, you know that you need to use the start method and not the run method, because otherwise this doesn't work. So let's look one more time at this code. What we're doing is we're just saying accept clients all the time. When a client actually connects, we're going to just say, okay, connected with this client, so that the server admin knows what's happening. Then we're going to send to the client the keyword nick, or the code word nick, so that the client knows, okay, I need to send my nickname. We're then going to receive the nickname from the client, append this nickname and this client to our lists. And then we're going to print on the server, again for the server admin, that the nickname of this client is whatever. Then we're going to broadcast to all the clients connected to the server that this client with this nickname now joined the chat. We're going to send a message to the particular client that the connection was successful, and then we're going to start a thread handling the connection to this particular client. So now we can actually start coding the client, but before we do that, I need to add one more line here. The receive method also needs to be called, because we defined all this, but we didn't run it. So the receive method is our main method, and it runs down here. We could actually also go ahead and run the server, but you're not going to see anything. But a good sign is that it's running and not crashing, so it probably works. But for the server to do something, of course, we need a client to connect to it, because otherwise it's not going to do anything. What we could do is we could just print out the message, server is listening, dot, and then you can see the server is listening. And that's how you run the server. Now, the next thing is we need to define the client. So we're going to say client.py. And here also we're going to import socket and import threading. And we're also going to define a socket. So we're going to say client equals socket.socket af, socket.af inet and socket.sockstream. There you go. And now instead of binding the client to a port and a host, we're going to connect it to a host and a port. So we're going to say client.connect, and we're going to connect it to localhost, so 127.0.0.1, and we're going to connect it on port 55555. And now we're connecting it to the server. So in this line, when this line gets executed, the server will receive will trigger the accept method, and the client is now connected to the server. So what we're going to do in this client is we're going to define two methods and run two threads simultaneously. So we're going to receive all the time data from the server. So we're going to have a receive function that's running constantly. And at the same time, we're going to send messages, or we need a thread running for all the messages that we're going to send. So let's start with the receiving part, define a function receive, and this function is just running again in a while true loop. And we're going to try something all the time. And what we're going to try is we're going to receive messages from the server. So in this case, we'll say client.receive, but the client is actually receiving from the server. So what we're going to do is we're going to say message equals client.receive. Just don't get confused. We're still receiving from the server, not from the client. But for the server to send messages, it uses a client, so it could be considered a client. So we're receiving 1024 bytes, and we're decoding what we receive. And that's basically it. Now what we need to do is we need to check if the message that we just received is nick or something else. So we're going to say, okay, if message equals nick, which is the keyword for sending the nickname, we're going to send the nickname. I'm just going to pass here because we need to get the nickname first in the beginning of the script. And if it's not nickname, what we're going to do is we're just going to print the message. So whenever we get a message from the server that's not nick or any other keyword that we define, we're just going to print the message because we're not going to do anything about it. We just want to see what the server has to tell us. So we're going to say message print, or print message. If that doesn't work, what we're going to do is we're just going to close the connection. So we're going to say an error occurred, and I think double R, I'm not sure. Oh man, I think it's misspelled. Yeah, double R. An error occurred, and then we're just going to close the connection. So we're going to say client close, and we're going to break this endless loop. Now, how are we going to send a nickname? First of all, we need the nickname, so we're going to say nickname equals input choose a nickname. So whenever we run a client, the first thing that we want to do is we want to choose a nickname. And if the message equals nick, what we're going to do is we're going to say client.send, and we're going to send the nickname, the encoded version, to the server. So what's happening here is the server is listening all the time. The client is choosing a nickname, connects to the server, and the moment this happens, this gets triggered. We say connected with whomever, and the first thing that the server then does is it sends the keyword nick. So we're going to get the keyword nick, we're going to send the client name or the nickname, then we're going to receive it here, append it, and whatever, and then we're having a connection. And as soon as the server sends something to us, we're going to receive it and print it onto our screen. Now let's finish off the client by defining the second function, which is the write function. And what this function does is it runs a while loop as well, an endless loop. And here what we do is we always define a new message. So we're going to say message equals f string, and here we're going to say nickname colon, and then the actual message. The actual message is always what the user puts into the script. So, I need to use double quotation marks here. What we're doing here is we're constantly running new input functions. So as soon as the user clicks enter and sends one input, we ask for the next one. So the only option that the user has is to either close the client or write new messages. So we are always waiting for new messages. This is a thread. Receive and write will run simultaneously, and the write function is always waiting for a new message. And you send a message by clicking the enter key. And once you get a message, so once you click enter or press enter, what happens is you say client.send, and we're sending the message, of course, encoded. And that's basically it. That's the whole function. And now what we need to do is we need to run two threads. We need to run a receive thread and a write thread. So we're going to say receive thread equals threading.thread with a target function of receive. We don't need any arguments here. And then we're going to say receive thread dot start. And then we're going to do the same thing for the writing thread. So write thread equals threading dot thread. And the target here is the write function. And we're going to start this thread as well. And now we're done with that. But the problem here is that in PyCharm, we can only run one client at a time, and to see how this works, we need to run one server and two clients. So I'm going to run this in a command line right now. So right here, I navigated 3 terminals into the direction of the TCP chat, and what I'm going to do on the left side here, this will be a server, and these 2 right terminals here are going to be the clients. So I'm going to just say Python server.py, and as you can see, server is listening. And here we're just going to say Python client, and we can choose a nickname. So for example, let's say neural9 is the nickname. And as you can see, we get connected with the IP address and the port. Nickname of the client is neural9. I can see here on the right, neural9 joined the chat because this is a broadcast message that gets sent to all the clients, including myself. And also connected to the server. And now we can run a second client. So we say Python client.py, and I can choose a nickname here. Let's say YouTube audience, so you guys. And you can see I get here again connected. Nickname is YouTube audience. Here I see YouTube audience joined the chat, connected to server. And here on neural9, I can see YouTube audience joined the chat. So I can say hi or hey YouTube. And then what happens here on the server, I don't see anything because the server is just monitoring the connections. And here on the client side, I see hey YouTube from myself. But also the YouTube audience here sees hey YouTube from neural9. So it can answer hey, what's up? And I can also see it up here. And I can also start spamming here if I want. And you'll see it in both clients. So this is how you do a professional advanced chat. Of course, you could also add some special commands like kick or ban or I don't know, emojis or something, but this is a basic version of a chat room.